All right, we're going to go ahead and get started here, man, in just a few seconds. I got one more joining the Zoom call, so I'm going to give him a couple minutes.
Awesome. Sounds good.
All right, we're just going to go ahead and get started. So, welcome. We're going to do CCNA this week. It's a condensed course, so because of the 4 day, it's going to be 4 days to try to get through as much CCNA training as we can. So, a lot of times, the training that I'm going to be conducting here in the live virtual session is going to be a lot of whiteboard. Just going through the technologies, hitting some things on the PowerPoint, obviously, because there's just going to be some things we want to see in writing that we want to, uh, memorize. But my goal here is just get through as much CCNA content as possible. Starting tomorrow, we're going to do some labs as well. So I like to be somewhat lab focused. Obviously, in a condensed version, there's going to be some labs we just don't do. But the basic ones like VLAN, trunking, Ether channel, static routes, OSPF, we'll definitely be conducting those labs. Hopefully, we get to our NAT lab because I know that may be something that's on the exam, NAT configuration. So just to go ahead, before I start the instruction, I just want to make sure that you have access to our learning management system. If you don't, just let me know. And if you don't have access to the learning management system, just hit me in the Zoom chat and we'll make sure to get that squared away on the next break. So it should look like this. So if we log out, I'll start with the log out. So if you come to academy.trepatech.com, you should be able to access the course material. Depending how you signed up, so I signed in with Google, but you might have not done the Google SSO, which is totally fine. And then if you come here to our courses, you should see CCNA, okay? Now our CCNA course, I'm going to show you everything that comes with it. So we have our course resources here. So we have our Google Drive. We have our Discord also that you can join. That comes with a network of IT professionals you can talk to, discuss things. Sometimes we do resume help, things like that, if you're ever looking for it. And then our GitLab repo. This is going to be where all of our labs are. So the Google Drive will start there as far as course resources. This is where you can download all of the slides. So you can download all the slides from here. EVNG, which is the network emulation software that we're going to use in this course that you're going to get access to via a cloud public IP. If you want to set that up at the house on your own computer, Windows machine, I give you all the files and downloadables that you would need for that EVNG setup. And then when we come do the labs, this is where you're going to access the public IP. So I'm going to give you a public IP with your name here, and it's going to change at the start of class every day. So tomorrow, you'll get a public IP. Then Thursday, you'll get a different one, and Friday, you'll get a different one to access the labs. We're going to get to the labs in just a second. Now, GitLab. This is where all the lab instructions are going to be. So Section 3 is where we start, is where you're going to do the VLAN lab. And I made my instructions pretty much like almost dummy-proof, where you can go line by line, step by step, and you'll be able to complete the labs. So GitLab is where all those lab instructions are going to be at, okay? And when we get there tomorrow, I'll walk through again where to access the lab instructions. These are just the instructions, and then where the actual lab is. Now, the actual learning management system. So we have exams here for you to practice that you have lifetime access to. Let me just refresh here. So you have all these different CCNA practice exams. So these practice exams are 50 questions each. Some are like drag and drop here. Some are going to be multiple choice Okay. We're going to skip a couple of these questions. But yeah, so you get lifetime access to some of these questions, okay? Or excuse me, you get lifetime access to all these questions here. Submit the answer. Some will have explanation, some won't. But yeah, you'll get lifetime access to all these questions here, and you can access this on your phone. We developed it to be very mobile friendly, and we also have an application that you can download where you can also access all these questions as well. So we come back here to access the lessons. So you can see all of our lessons here. This is going to have the video lessons. So this is going to have all the video lessons here at the learning management system that you can access, again, from your phone or from our mobile application. To download the mobile app, since it's in beta, it's not just from the App Store. So if you have an Android phone, it's real easy. You just have to download this APK. That's the file extension for, Android apps. If you have iOS, from your phone, you'll log into this. You'll go to this URL from your phone. You'll hit install test flight. It'll download what's called the beta testing app. And then you'll come back to this link and hit install Trepid Technologies. And then that'll install our own custom built app. We had to keep it in beta like this just because the App Store has some crazy rules. So anyways, so that's how you download the app if you're on iOS. Now, for the live virtual training sessions, right? We're going to be going over some slides, but most of it's going to be whiteboard and hands-on. So when it comes to your virtual labs, we use an emulation software called EvenG, which is going to actually emulate real Cisco IOSs. So I have a VM created here. This is my VM. I'm going to create you and Chase, the other student that's going to be hopefully joining the class. Your own VM with your own public IP that, again, will change every day. So I'm going to be giving you this IP, and when you log in here, the username is admin, and the password is Eve. And then you're going to log in with the HTML5 console, and you're going to hit sign in. And then you're going to get access to all these labs, okay? So let me just show you here. Let me stop all these nodes. Close the lab. 1 second. So yeah, EvenG, this one's been running, so it's going to be a little laggy right now. But this is going to be real network emulation. So there's going to be actual Cisco IOSs in this lab. 1 second here. Okay, these switches are I'm going to restart this VM. That's why I restart them at the end of every day too, because if you just leave them running, sometimes it just gets hung up here. But we'll go over that after the next break. But yes, so this is the lab software that you're going to be using, okay? And you'll get used to it throughout the week. So these labs in this VM that I'm going to create for you will be available. It'll be available for just the duration of this course. And I'm going to leave them running at the start of each day. So at 9 a.m. And I'm going to leave them running till about 10 p.m. East Coast time, okay? So you'll be able to access it throughout the day if you want to access your labs. If you're on a government system, though, on Unclass, I don't think you'll be able to reach it because it's HTTP, not HTTPS. So it'll have to be on a personal computer. All right, awesome. So if you don't have any questions, we're going to go ahead and take our first 5. We'll take a 10-minute break here, and then we'll go ahead and get started again at 5:20.
Awesome. Yeah, I got one quick question. I just wasn't given I guess because this is through my company, I wasn't given a TrepidTech login to get to all that stuff. Is that something I need to make or?
All right, let's go ahead and get started now. So we're going to start off by going over what the CCNA and the Cisco certification is. So Cisco certification. So Cisco is not just a training vendor like something like CompTIA would be. Cisco is a network enterprise vendor, sells hardware, software solutions, recently getting into cybersecurity because they just like bought out Splunk. But they also have a certification track like most major vendors will have. Cisco is probably one of the biggest though when it comes to networking and technologies related to networking. They've been doing certification since like the late 90s. So what we're looking at here is the CCNA. You can see up top here, they have 4 different levels: entry, associate, professional, and expert. And it scales way up when you go from professional to expert. But the CCNA is associate level exam. And this is going to be in the enterprise technology. What that pretty much says is that the CCNA is going to go over anything that you could find in your typical enterprise, which would be routing, switching, wireless, security, and automation. The professional level, as you can see, it kind of dives into a little bit different flavors or different technologies. So you have CCNP Enterprise, you have CCNP Security, Service Provider. We have the DevNet track, which is going over purely network automation. And then we have the security track up here, cybersecurity. We have CCNP Collaboration, also data center. And then from professional down, so from the entry, associate, and professional level certs, those are all going to be through Pearson VUE. So they're going to be like multiple choice questions. CCNP Enterprise just recently made a change where the first half's all labs, but it's through a Pearson VUE test center. Once you get to the expert level, CCIE, all the expert level tracks, that's going to be an actual lab like at Cisco or at a verified place through Cisco, and it's like an 8-hour lab. That's going to be like the top 5-10% of anyone that's ever done networking or IT will be at this CCIE level. Right now, we're just focused on the CCNA. So the CCNA puts you somewhere in between junior network admin to network engineer. Now, obviously, a lot of that's just based off your skill and expertise, but the CCNA as just a certification typically signifies, hey, I can operate at least a network admin level, right? I can go through, I can troubleshoot switching, basic routing, and have a basic understanding of enterprise networking. Okay, so what does certification mean for you? You could be getting your first job in IT. You could be making a change in your IT career. Some colleges will recognize CCNA for some credits. It could be for career improvement. So let's say you're working as like a field service rep, help desk technician, and you want to get into the NOC, get into the network operations, eventually become that network engineer, making that 6-figure salary, right? Well, the CCNA can help you. It can help show your employer that, hey, I'm willing to learn networking, and I want to get into the networking field. All right, awesome. So now that we went over what the CCNA is, let's actually get into what is networking. What is networking technologies? Okay, so what is networking? So this is an all-encompassing term which refers to design, management, the deployment, the troubleshooting of network infrastructure. So we think of network infrastructure, and we think about the enterprise, that is just making sure that packet A gets to its destination. From client to server, we have end-to-end reachability. So that's what networking is. We don't worry about the application. We don't worry about the software development. We manage, troubleshoot, and deploy the networking infrastructure that keeps us online. So again, network professionals install, maintain, manage, and troubleshoot the infrastructure that enables data to traverse the globe. With the internet being the largest network with there's probably more than even 5 billion daily users in it. Networking in the enterprise, though. So when you usually get your start, you typically don't go work at a major ISP. You typically start what we call the enterprise. Whether that be working at an MSP, working at like a bank or a hospital or whatever industry you work in, multiple sites, big campus networks, supporting a bunch of different users and maybe customers as well. So network professionals do most of their work in what we call the enterprise or the intranet. What you don't see on the internet. All these web servers that are hosted in the cloud or hosted on like other platforms like Bluehost, wherever the case may be, a network engineer didn't set up that server, right? Networking typically is in a big organization within its own domain. So what we have here, let's say this is a bank. And we have our hub, our main office here with like a little on-prem data center. And then we have all of our spoke offices. This could be all of our banking offices, right? Other smaller cities. Well, they all need connection back to the main office here. Their users all need connection to the internet and to their resources that may sit here on the data center or resources that may sit in a cloud somewhere. So maybe they have telephony technologies here, communication services like desk phones that we also need to manage and maintain. We have switches there that need to be managed and maintained. We may have network segmentation there. We may have VPN connections from our customer edge router here through the local ISP that also needs to have someone as the point of contact working with those ISPs in whatever region of the world or country you're in, connecting back to our main office here. All that is the network engineer or the network admin, making sure that's possible. making sure that the architecture from end to end has reachability within our enterprise, okay? And we see that customer edge here. That's because that's pretty much what we like to call our demarcation point. The point at which we no longer have control, that's our uplink to the ISP. Where we do have control, which is at this customer edge and down, and then at all of our infrastructure here, that's what we're going to manage and maintain. So a typical CCNA will start his or her career working on network infrastructure in the actual enterprise. So we have a little bit of history of the internet. So the very beginning of what we call the modern internet, right? There was something called ARPANET, which just was there to link universities together to share files, to share research with each other. And the ARPANET was funded by DARPA, right? So that's the Department of Defense, DARPANET, that does still defense research and development. They started the internet. It used to be called NCP for switching packets, and then in 1983, TCP/IP replaced that, and that became the standard protocol which we see today. We still use the TCP/IP protocol suite in the internet, in networking. So your role. So as a CCNA, it's your job to ensure that the critical infrastructure that connects us stays online. That's it. You make sure that the internet stays on. That's your entire role as a network admin. Kind of think of it like plumbing, like a network engineer is just making sure that the plumbing's working correctly in your network infrastructure. That's like a common thing amongst like seasoned network engineers. You know, we're not developing apps. We're just making sure that things are running smoothly and highly available for our users from end to end. Okay, now let's go over the network components. So we understand that. We know what our role is. Okay, we get it. You know, we can beat that over our heads 100 million times. We make sure that the internet stays online for our users, right? What they consider the internet, which we know is just our network infrastructure, our enterprise. But what are the network components that we need to be aware of? What are the network components that we will be managing? So we're going to start off here with a switch. So a switch is a layer 2 device that's going to switch frames, okay? I'm going to bring up the whiteboard for this. So I'm going to stop sharing my screen here for a second and actually just share a whiteboard here. Let's see. Okay, so this is going to be our CCNA whiteboard that we'll be using for the majority of class. All right. So layer 2. And we're going over network components. This is going to be a switch. So what does that switch do? So when we draw out a switch, we typically design it like this for like our basic access switch. So high level overview, a switch is there to switch frames within a local area network. It does that by looking at the source and destination MAC addresses and installing source MAC addresses into a MAC address table and then looking up the destination MAC address based off what is stored in its MAC address table. So the brain of the switch is going to be something called a CAM or MAC address table. So that MAC address table is going to tell us which MAC addresses live on which ports. And every single device that connects to a switch, so we take our RJ45, we take our Ethernet cable, connect it to our laptop or our desktop. It goes into the wall jack, but behind that wall jack is a patch panel and a comms closet that connects it to a network switch. Every single NIC, network interface card, on that desktop, laptop is going to have what's called a MAC address, a BIA, a burned-in address that makes it unique and recognizable on a local area network. MAC address. A MAC address is 12 hexadecimal digits. 12 hexadecimal digits. So that's 0 through 9 and A through F. That's hexadecimal. Now, a typical MAC address, like let's say we have PCA here. So if we want to write out this MAC address, the first 6 digits is going to be a vendor OUI. So the first 6 digits, let's say it's 00:11:22. That's a 2. This is going to be called the vendor OUI. So if this is like a Dell computer, we can look up the first 6 digits of a MAC address and see what vendor created that device. So Dell, Cisco, HP, Lenovo, whatever the case may be. And then the last 6 hexadecimal digits, so let's just say 33:11:11, is going to be unique to the device. It's going to be unique to that device, okay? Just to break down MAC addresses. So when PCA first communicates with, let's say this is switch 1, it's going to create a frame. Now that frame is going to look something like this. So our layer 2 frame is going to have what's called a layer 2 header on it. Now there's going to be something in front of it called a preamble, but we're just going over the strictly layer 2 header. So that L2 header is going to have a destination MAC address and a source MAC address, okay? So this will be the source MAC, destination MAC. So that source MAC will be whatever PCA is. And just for brevity reasons, I'm just going to use the last 4 here. 1. And let's say we have another PC over here. We have PCB. And its MAC address is 22:::22. Now I'm shortening them up because I don't want to write all 12 hexadecimal digits, right? So we want to talk to PCB here. Now, when this PC, and then behind this layer 2 header, guys, is going to be the data payload. So data payload. And that's going to be 1500 bytes maximum. And then at the end here, we have something called the FCS field. The frame check sequencing field, which also is going to allow us to check on like our cycle redundancy checks and make sure that nothing's missing in the frame. But, okay. When PCA communicates to that switch, 2 things it's going to do. 1, it's going to take that inbound source MAC address, 11, and put it into the MAC address table. So let's say this is gig 0/1. It's going to say, okay, on gig 0/1 lives MAC address 11:11. Now again, this would be a full MAC address, okay? It's going to insert that. And then after it inserts that source MAC address table, it just looks up to see if it has it, right? It's going to take a look at the destination MAC. And when it takes a look at the destination MAC address, the switch, it's going to reference the CAM table. It's going to say, okay, do I know where this MAC address is? Well, let me check my MAC address table. And if I do know where it is, so let's say this is on gig 0/2, it's just going to forward that frame. So it's going to forward frames based off destination MAC, but it's going to build its MAC address table based off the ingress, based off the source MAC address, okay? Now, we're not going to dive into, well, what happens when it doesn't know where the destination MAC address is, because we have a condensed timeline, and we'll get to that. But there is something called unknown MAC address switch forwarding, right? Or how do we forward a frame when we have an unknown MAC address? We're going to go over that later on, okay? But that's what a switch is. So a switch, which we have to maintain, forwards based off destination MAC address, and the brain of that switch is the MAC address table, or known as the CAM table, which stands for Content Addressable Memory. Okay, next, we're going to go over a router. Now, let me go back to the slide. Or actually, I don't want to keep unsharing and sharing. So next, we're going to go over a router, okay? That's going to be the next network component we're going to talk about, which is the layer 3 device. So next device we're going to talk about is a layer 3 device. That is a router. So a router now works with IP addresses. So a router's whole purpose is to forward IP-based packets. So here's how it functions. So let's say we have R1 here, okay? And connected to R1, we have a local area network. And that local area network, I'm going to draw this in blue, is this subnet, 10.0.0.0/24. And then R1 has a connection over here to R2. Okay? Has connection over here to R2. And R2 has a local area network. I'm going to draw this in. Let's say orange. That works. Of 10.1.0.0/24. So my users over here hanging off R1 want to talk to the users over here in R2. Well, how do we do that? How do we communicate outside our local area network? Well, this gets into how a router functions. A router forwards based off IP address. IP addressing is what allows us to communicate over the network, over the internet. So when I have a PC here, so let's say this is PC A that wants to talk to PCB over here. Let's say PCB's IP address is 10.1.0.10. Let's say PCA's IP address is 10.0.0.15. Here's what we do. Now we're going to build a layer 3 header. And now we're going to be building a packet. Okay? We still have the layer 2 header, but I'm not going to draw that out. We'll still have that because this is getting into encapsulation and how it actually happens. But now we're going to have a layer 3 header added onto that. So our layer 3 header, so this is our L3 header. Let me move it down. And then we'll also have like a data payload that I'm just going to draw like this. Obviously, it'd be a lot bigger than just the layer 3 header because it can be up to 1500 bytes. We're going to have a source IP and a destination IP. Okay? Now, this is going to be forwarded to our default gateway. That's going to be based off the layer 2 header. That gets into stuff like ARP, and we're just not going to get into it because we're going over what a router does, right? We're building. So the source IP is going to be 10.0.0.15. The destination IP is going to be 10.1.0.10. So when I forward, or when the R1 receives this packet, here's what R1 does. R1 now is going to reference what's called the global routing table. R1 is going to reference that global routing table. Sometimes we will also refer to as a RIB, a routing information base. But this is the routing table. And that routing table is going to determine if the router knows where to send destination packets. And what we mean by that is the router is going to look at that destination IP, say, okay, 10.1.0.10. Let me reference my routing table and see if I know where to send that. So let's say it did learn where that network is, the 10.1.00/24 network via OSPF. So we enabled a dynamic routing protocol called OSPF over serial 00, and R2 did the same thing. It enabled OSPF, and now these two are OSPF neighbors, and using a dynamic routing protocol, they share with their neighbors their locally known routes, or older known routes and networks. So now in R1's routing table, it says, hey, if I want to talk to the 10.1.00 network, I need to go out serial 00. And I learned that via OSPF. That's what that O is right there, okay? R2, so we have full reachability, did the same thing. Now remember, in the background, these two routers are OSPF neighbors. So we configured OSPF in the background, and they're part of area 0. That's, again, something beyond, but routers share with each other their known routes using a dynamic routing protocol, or we can also configure static routing as well. But again, we'll get into that later. And the routers reference their routing tables when receiving incoming packets with a destination IP beyond the local area network to see if it knows where to send that packet. So then on R2, we're going to say, hey, if we want to reach this network, we're going to go out serial 00. And that's what a router does. In its base form, right, that's all a router is there for. To route packets to a destination. That's it. To route traffic based off IP addressing. Now, an integrated service router, like if we're small to medium-sized business, it can do a lot more. So the ISR platform of like Cisco, the integrated service router, it can maybe do telephony technologies. It can be a VPN concentrator. It can do a lot more than just routing. But when we get into like an ASR platform at Cisco, those are our big core WAN routers that are just dedicating for routing. That's it, okay? So that's what a router does. Okay, now moving on. So I'm not going to put this at layer 4. We're just going to say the next network component is a firewall. Yes, sometimes it can operate at layer 3, 4, and layer 7, depending, because we have next generation firewalls, application aware firewalls, and things like that nowadays. So, but a firewall. So a firewall is another networking device that's going to allow us to filter inbound and outbound traffic. Okay, let me right there. So traditional firewall, let's start there. That's a little bit easier to understand. Traditional firewall, what did it do? It separated our network into zones, into a trusted and an untrusted zone. So let's say I had a firewall here. Okay, and on this side would be my intranet, my enterprise. And we would call this the trusted zone. Trusted. So we would filter inbound here, right? And outbound maybe, but so we don't want users. Maybe we're doing URL inspection, things like that. We don't want our users to, go to a malicious website, things like that.